Hello, I am Amandine from the LAAS and I'm going to talk to you about our work on the real-time evaluation of the quality of interaction when the robot and the human perform a collaborative task together. When humans interact with each other, collaborating on a shared activity or chatting, they are able to tell to a certain extent whether their interaction is going well or not. This knowledge allows humans to adapt their behavior. So, we think it is desirable to provide robots with means to measure in real time the quality of the interaction with their human partners and then use this information in its decision-making process. For example, if the human asks multiple times the robot to repeat when it says something, it's not normal. Then the quality of the interaction is not very good. The robot can act to improve it by increasing the volume of its speakers, for example. In the work I'm presenting you today, we focus on the measurement of the quality of interaction and not on the decision-making process fed by this measurement. In the literature, the HRI field has elaborated a lot of methods evaluating interactions from the human point of view with questionnaires and other methods of offline evaluation. We are more interested in works evaluating the interaction with objective measures, like the ones of Steinfeld and colleagues, or Hoffman proposing sets of objective metrics to assess the system performance by measuring the task effectiveness or the task fluency. But they are not designed to assess the task in real time. In the domain of real-time evaluations, Tanevska and colleagues offer the way to measure the human affective and engagement states. However, human affective state measures may not be enough to assess a task, as an affective state is a facial expression which can be misinterpreted and might be not visible when one of the agents performs an action and looks somewhere else. Bench and colleagues propose a formal approach to compute interaction quality in real time, but without offering an example of implementation, remaining at a high level of abstraction. Therefore, there is a lack of methods allowing the robot to evaluate in real time the quality of interaction based on multiple metrics. To fill the gap in the literature, we proposed a way to compute the QOI based on the measurements of metrics during a collaborative task. Then, as a proof of concept, we implemented the first version of the evaluation system. The real-time evaluation process performs computations every 1 second. First, it gets the measurements of selected metrics. Then, with an equation that I will not describe here, it computes a QI value for the ongoing action, using the measurements of the metrics selected for this given action. It also computes a QI value for the task, based on the metrics selected for the given task and based on the action QIs previously computed, as the task quality depends on the action's quality. The two output values are between -1, representing a poor quality of interaction, and 1, representing a high quality. Now that we have seen the overall functioning of the estimation process, I'm going to present you the generic set of metrics we defined. We divided it in two: the metrics related to human engagement and the ones related to task and action effectiveness. We defined 2 metrics to measure the human engagement in real time. The first one, human contribution to the goal, is here to evaluate how well the human performs during the task. For example, does they put the right cube at the right place at the right moment? The purpose of the second metric, fulfilling robot expectations, is to measure if the human is behaving the way the robot expects when the robot is acting. For example, when the robot speaks to the human, it will expect them to look at it. We defined 3 metrics to measure the effectiveness in real time. The first one, variation in the distance to the goal, measures if the agent is getting closer to its target position over time. During a normal execution, at every time step, the remaining distance should be shorter than at the previous time step. The second metric compares the current estimated time to the goal with the initial estimated time to the goal, taking into account the current task duration. If the action is supposed to last 5 seconds when it starts, but after 2 seconds of execution, the remaining time is still 5 seconds, something is not going well. Finally, the last metric checks if the duration of the ongoing action or task is going over the usual time of execution or not. In the context of the Member European project, we worked on a guiding task. The robot gives guidance by pointing at places and explaining the route to the wanting location, moving in a limited area to place itself in a configuration where the landmarks it decides to indicate are visible to the human. Here are examples of the metrics selected for 2 actions of the task. For instance, when the robot asks a question to the human, we can estimate that the action has a good quality if the human is attentive and answers with a response consistent with the question. The measurements of these two metrics are computed together to give as a result the QI of the action when it's executing. Another example for the QI measure of an action is the variation in the time to the goal when the robot is navigating. We can notice that the QI for this action takes into account only one metric. Finally, for the guiding task, the QI is computed from the aggregation of the action QIs from one metric, which measures if the subtasks are executing in their usual execution time. For example, the question-answer process should not take more than 15 seconds. We did a first proof of concept of the real-time evaluation system in the lab with one person. We did 3 recordings, one with a human behaving exactly as expected, one with a human confused, slow, or making small mistakes, and finally, one with a non-cooperative human doing everything to bother the robot. On the graphs, in orange are the actions QIs, and in blue the task QIs. As you can see, the measured QI is much lower for the non-cooperative human than for the confused one. I presented you a system evaluating in real time the quality of interaction during a collaborative task. In the future, we will conduct a user study to further validate our system. We also plan to integrate the evaluation system into the decision-making process so the robot can react and refine its decision according to the QI values. Finally, this set of metrics is not exhaustive and will be expanded. Thank you for your attention, and I can answer your question during the live session.